Imagine a star so incomprehensibly massive that if you placed it exactly where our Sun is right now, its boiling surface would instantly swallow Mercury, Venus, Earth, Mars, and Jupiter. This is UY Scuti. And scientists around the world are currently divided on how it even exists. At a staggering 2.4 billion kilometers across, it holds the volume of 5 billion of our suns. It actively flirts with the very limits of physics, a boundary called the Eddington limit. If it gets any bigger, it should literally tear itself apart. But here is where it gets crazy. It might actually be doing exactly that. To understand this anomaly, we have to look at what we consider normal. Our Sun feels massive to us. You could fit 1.3 million Earths inside it. It is held together by a perfect, billions of years old balance, gravity pulling inward, and nuclear fusion pushing outward. It is stable. Predictable. But this is where things get strange. When you venture 9,500 light-years away toward the constellation Scutum, that cosmic balance shatters. What we found hiding in the dust makes our home star look like a single, insignificant grain of sand. Before we dive into the terrifying core of this cosmic giant, make sure you hit that follow button. What I am about to reveal next regarding its impending hyperdeath is exactly why thousands of space lovers are joining us every single day. Stay with me here, because what you are about to see changes everything. The year was 1860. German astronomers at the Bonn Observatory noticed a faint, blinking speck of light. They catalogued it as BD 125055. For over a century, it was just a meaningless number on a chart. But then, modern instruments like the Very Large Telescope in Chile aimed their lenses directly at it. The data came back, and astronomers were stunned. By 2012, we realized this was not just a star. It was a pulsating, dying monster. And it was acting completely erratically. Here is the leading theory on how UY Scuti became the king of stars. It is a red supergiant. It ran out of its primary hydrogen fuel and started panic-burning helium, then carbon, forcing its outer layers to expand violently. Think of it like a cosmic hot air balloon where the burner is jammed on full blast. But this raises a massive problem. How does it hold on to its outer edges when gravity out there is incredibly weak? The answer to that leads to a terrifying twist. Just when you thought you understood the scale of this giant, new data dropped a bombshell. Recent measurements from the Gaia Space Observatory suggest UY Scuti might actually be closer to us than we thought, meaning it could be smaller than our previous estimates. Others claim it is breathing, pulsing and changing its size by millions of miles every few years. And waiting in the shadows, a newly discovered contender, Stephenson 2-18, threatens to steal the crown entirely. The astronomical debate is raging. I genuinely want to know what you think. Are our best instruments simply incapable of measuring these cosmic leviathans accurately through the galactic dust? Or is there an entirely different class of hyperstars we do not yet understand? I want you to drop your wildest theories below right now. Is UY Scuti the absolute physical limit of the universe, or is there something even bigger hiding in the dark? Let's debate in the comments. This affects how we see our place in the universe. UY Scuti's gravity is so weak at its edges that it is shedding 58 million Earth masses of material every single year, bleeding out into the cosmos. When this star finally dies, it will not just go supernova. It will trigger a hypernova, collapsing inward into a black hole and seeding the galaxy with heavy elements. By the end of this video, you will understand that we are not just looking at a freakishly large star, we are watching the messy, violent birth of future solar systems. But there is incredible hope for definitive answers. The James Webb Space Telescope is now peering through the cosmic dust that hides these behemoths. Scientists around the world are tracking the death throes of red supergiants with unprecedented clarity. We are on the verge of mapping the exact life cycle of these impossible objects. Science is progressing faster than ever, and within this decade, we may finally witness the final, explosive breath of a giant like UY Scuti in real time. But UY Scuti is not the only cosmic monster challenging everything we know. What happens when a star collapses into a void so dense it consumes entire galaxies? In our next videos, we are exposing TON 618, the largest black hole ever discovered, and the Great Attractor, the invisible gravitational anomaly dragging our entire Milky Way toward it. You will not want to miss them. Thank you for joining me on this journey into the deep. Remember, you and I are made of the exact same stardust forged in the bellies of dying giants just like UY Scuti. The universe is full of secrets, and we are just getting started. Stay curious, keep looking up.